So in this example, we're given a simple circuit and we're asked to determine the current in the 3 ohm resistor. So that would be this current going through this resistor, which we're calling I3. They want us to use Kirchhoff's voltage and current laws to do this. So the first step we need to do is do some nodal analysis using Kirchhoff's law. And we're going to start by looking at this node here. And we want to sum all of the currents going in and out. So again, starting there, we want to sum the currents at node B. And so to do that, we need to come up with a convention. So we're going to say leaving the node is positive, entering the node is negative. So we see that there are 3 paths here from this node, 1, 2, 3. And so when we look at that, we know we have I3 defined through the 3 ohm resistor. And then we have through the 9 ohm resistor, we have I9. So we'll say plus I9. And then we see through this leg, we have 3 amps entering. So because we defined going away from the node as positive, that has to be negative. So there'll be minus 3. And that all has to equal 0 because we have to conserve the energy or conserve the current. So that's our first equation. So now we want to take a look at a loop. We're instead of a nodal analysis, we're going to do a loop analysis. And so we want to take a look at this loop right here. And we want to sum the voltages around that loop. And to set our convention, we're going to say that we're going to go counterclockwise around the loop. That's positive. Okay, so again, we want to sum up the voltages this time around our loop. And so to do that, we'll start at point A. So we'll start at this point here, and we'll start traveling in this direction. And we see the first component we come to is the 9 ohm resistor. And we hit the negative side of that first with the convention of the current that we defined. So then that will be a negative. We'll just call it V9 for voltage across the 9 ohm resistor. So now we continue around our loop. And we see we come to the 3 ohm resistor. And in this case, we hit the positive first because we're going in the same direction of our I3 current. So that'll be plus, we'll say that's V3. And then as we continue around our loop, we encounter our voltage supply, and we hit the negative side first. And so that's simply minus 18. And again, that all has to equal to 0 because we have to conserve energy. So this is the 2 equations, and from this we can now manipulate these equations a little bit. So now I'm going to invoke that V is equal to IR, Ohm's law, and so I'll transform this equation. And so when I do that, and I'm going to rearrange the values. In other words, just swap these two to put the 3 ohm component first. So V3 then is equal to IR. So the I is I3, and the resistance is 3 ohms. So that's that component. Next we have our minus V9. So now that's going to be minus the current is I9, and the resistance is 9 ohms. And then this just stays the same. We'll move it to the other side. So we add 18 to both sides, and that'll equal to 18. So now we have 2 equations, 2 unknowns. We can further simplify this by dividing each of these by 3 throughout. And so when we do that, we're left with I3 minus 9I9, and that is going to equal to 6. So now I want to just bring this down now. So first we'll just bring down this equation just as it is. So that's I3 plus I9. And I want to move the 3 over to the other side. So add 3 to both sides, and that'll equal to 3. And now I'm going to move this equation down. So now that's going to be I3. It's going to be minus 3I9. So yeah, this should be a 3 here. And then that's going to equal to 6. So again, 2 equations, 2 unknowns. So I'm trying to solve for I3. That's what they've asked for us to determine. That's the current through the 3 ohm resistor. So to do this, I'm going to take the first equation here. I'm just going to multiply through it by 3. So when I do, I get 3I3 plus 3I9, and that's going to equal to 9. And the bottom equation, I'm just going to copy it over the way it is. So that's I3 minus 3I9, and that's equal to 6. So now I can just simply add these 2 equations together. That's allowed from our linear algebra class. And so when we do that, we get 3I3 plus I3 is equal to 4I3. These 2 will cancel out, plus and a minus, so that's just plus 0. And then this is going to equal to 15. So now if I solve for I3 by dividing by 4 on each side, I should see that I3 is now equal to 15 over 4, or in decimal form, that's 3.75 amps. So that's what they asked us for, was the current through this resistor. So I3 then is what we solved for, the current through that resistor.